GFCI, or ground fault circuit interrupter, protection is crucial for safety, especially in older homes with two-wire electrical systems lacking a dedicated ground wire. Several options exist for installing GFCI protection in these situations. Firstly, consider replacing the existing two-wire system with a three-wire system, which includes a hot wire, a neutral wire, and a ground wire. This is generally considered the safest and most compliant option, providing a dedicated path for fault current to return to the source, tripping the circuit breaker or GFCI device. However, replacing the wiring can be an extensive and costly electrical project. Secondly, you can install a GFCI circuit breaker in the main electrical panel. This type of breaker is designed to detect imbalances in current between the hot and neutral wires, indicating a ground fault. To make it work with a two-wire system, connect the neutral bonding jumper from the GFCI breaker to the ground bus bar in the panel. This effectively creates a ground reference for the GFCI breaker to function correctly. This option provides GFCI protection for all outlets in the circuit. However, it is important to note that it may not be compatible with all electrical panels, so consult with a qualified electrician before proceeding. Thirdly, a GFCI outlet with a pigtail can be installed. This involves installing a GFCI outlet at the first outlet location in the circuit. Then connect a ground wire, often referred to as a pigtail, from the GFCI outlet to a nearby metal junction box or a cold water pipe. This creates a ground path for the GFCI outlet to function. This option provides GFCI protection for all downstream outlets connected to the same circuit. However, it is essential to ensure that the pigtail is properly connected and secured and is not connected to any live wiring. Improper grounding can create a dangerous situation. Fourthly, you can consider a GFCI outlet with a neutral bonding jumper. Similar to the previous option, you install a GFCI outlet at the beginning of the circuit. Then, you connect the neutral bonding jumper from the GFCI outlet to the ground screw on the outlet itself. This provides GFCI protection for the outlet itself, but it does not extend the protection to any downstream outlets. This is generally considered a less desirable option compared to providing protection for the entire circuit. Fifthly, in some situations, a GFCI power strip can provide temporary GFCI protection for appliances and devices. You plug the GFCI power strip into an existing ungrounded outlet and then connect the devices to the power strip. The power strip provides GFCI protection for the devices plugged into it, but it is important to understand that this is a temporary solution and not a permanent fix for the underlying lack of grounding in the electrical system. Regardless of the option chosen, safety should always be the top priority. Always consult with a qualified and licensed electrician before attempting any electrical work, especially in older homes with potentially outdated wiring. An electrician can properly assess the situation, identify any existing hazards, and recommend the most appropriate and safe solution for installing GFCI protection. Ensure that any ground connections are properly made and meet all applicable local building codes and regulations. Improper grounding can create a shock hazard or prevent the GFCI device from functioning correctly. It is also essential to regularly test GFCI outlets and circuit breakers to ensure that they are functioning correctly. Most GFCI devices have a test button that simulates a ground fault condition. Pressing the test button should cause the GFCI device to trip, indicating that it is working properly. If the GFCI device does not trip when the test button is pressed, it should be replaced immediately. When dealing with older homes, it is often necessary to carefully inspect the existing wiring for any signs of damage or deterioration. Old wiring can become brittle, cracked, or frayed over time, increasing the risk of electrical shock or fire. If any damaged wiring is found, it should be replaced by a qualified electrician. Furthermore, be aware of the potential for asbestos in older homes, particularly in insulation around wiring. If asbestos is suspected, it is essential to have it tested and removed by a qualified asbestos abatement professional. When installing GFCI protection, it is crucial to understand the difference between a grounded and an ungrounded circuit. A grounded circuit has a dedicated ground wire that provides a low impedance path for fault current to return to the source. An ungrounded circuit, on the other hand, does not have a dedicated ground wire. In an ungrounded circuit, the GFCI device relies on detecting an imbalance in current between the hot and neutral wires to trip and interrupt the circuit. The National Electrical Code, or NEC, provides specific requirements for GFCI protection in various locations throughout the home, including bathrooms, kitchens, garages, and outdoor areas. It is important to consult the NEC and local building codes to ensure compliance with all applicable regulations. When using a GFCI outlet with a pigtail, it is essential to verify that the metal junction box or water pipe to which the pigtail is connected is properly grounded. A simple way to test this is to use a multimeter to measure the voltage between the neutral wire and the metal junction box or water pipe. If the voltage is close to 0 volts, it indicates that the junction box or water pipe is properly grounded. If the voltage is significantly higher than 0 volts, it indicates that the grounding is inadequate and an alternative grounding method should be used. In some cases, it may be necessary to install a dedicated grounding electrode, such as a ground rod, to provide a proper ground for the GFCI outlet. The ground rod should be driven into the earth and connected to the electrical system with a grounding conductor. The NEC specifies the minimum size and length of the ground rod and the grounding conductor. When installing a GFCI circuit breaker, it is important to follow the manufacturer's instructions carefully. GFCI circuit breakers typically have a test button and a reset button. After installing the breaker, it should be tested by pressing the test button. The breaker should trip, interrupting the circuit. To restore power to the circuit, the reset button should be pressed. If the breaker does not trip when the test button is pressed, or if it trips frequently for no apparent reason, it should be replaced. In addition to GFCI protection, it is also important to consider other safety measures when dealing with older electrical systems. These measures may include installing arc fault circuit interrupters, or SIs, which are designed to protect against arc faults, a common cause of electrical fires. SIs detect abnormal electrical arcs and trip the circuit breaker to prevent a fire from starting. Smoke detectors should also be installed in every bedroom and on every level of the home. Smoke detectors provide an early warning of a fire, giving occupants time to escape safely. Carbon monoxide detectors should also be installed, especially if the home has gas-burning appliances. Carbon monoxide is a colorless and odorless gas that can be deadly. Carbon monoxide detectors provide an early warning of carbon monoxide buildup, allowing occupants to evacuate the home and seek medical attention. When working with electrical wiring, it is always important to use proper safety equipment, including insulated tools, rubber gloves, and safety glasses. These items can help protect against electrical shock and other injuries. Never work on electrical wiring while standing in water or on a damp surface. Water is an excellent conductor of electricity, and standing in water can increase the risk of electrical shock. Always turn off the power to the circuit before working on any electrical wiring. The easiest way to do this is to turn off the circuit breaker that controls the circuit. However, it is also important to verify that the power is off by using a voltage tester to check the wires before touching them. Even with the circuit breaker turned off, there may still be residual voltage in the wires, so it is essential to use a voltage tester to confirm that the power is off. If you are not comfortable working with electrical wiring, it is always best to hire a qualified electrician to do the work for you. The electricians have the training, experience, and equipment necessary to safely and properly install GFCI protection and other electrical components. Trying to do electrical work yourself without the proper knowledge and skills can be dangerous and can lead to serious injury or property damage. In summary, providing GFCI protection in older homes with two-wire electrical systems requires careful consideration of the various options available and adherence to all applicable safety codes and regulations. Consulting with a qualified electrician is always recommended to ensure that the work is done safely and properly. By taking the necessary precautions, it is possible to significantly reduce the risk of electrical shock and fire in older homes.